Okay, so up to this point in your mathematics, if you haven't taken trig before, namely, you've always done coordinates in an xy plane with an x and a y. You've always found locations by knowing the distance away from the x-axis and the distance away from the y-axis, and that's how you find points. That is not the only way to find points. Today we're going to talk about polar coordinates and talk about how we convert between basically polar coordinates and what we call the coordinates you're used to seeing, which are called rectangular coordinates. Okay? So polar coordinates are an alternate way of looking at a point, and instead of basing it on the distance from the x-axis and the distance from the y-axis, we base it on the distance away from the origin, okay? And we base it on the angle that we have moved through to get to that point. And as we've done in trig so often already, angles are measured from the positive x-axis. So polar coordinates have the form r theta. R is the distance from the origin. Theta is the angle that we've moved through from the x-axis to get there. Now, the interesting thing about polar coordinates as a rule of thumb is that with rectangular coordinates, the ones you're used to using, every point has exactly one ordered pair. Right? You probably never thought of that as being a particularly useful piece of information, but it is a very useful piece of information because polar coordinates do not have that feature. Every point in the, axis can be represented in multiple ways if you're using polar coordinates. And that can be useful. It can also be a little bit distracting, so you have to be a little careful on how you're thinking about that. So the first thing we're going to do is we're just going to get used to this idea of what it would look like to plot a point. Okay, you've plotted points forever, probably middle school and up is when you first saw, maybe even late elementary school plotting points. And now you're going to plot them in a different way. So again, the first thing that might help you to remember is that you're not dealing with x and y here. This is r and this is theta. So jot yourself a note so you don't sort of slip up into the, traditional way that you've been thinking about points. Now, if we were to go, let's see how to say this correctly. Yeah, let me say it that way. If this value said 3 at the beginning as opposed to -3, we would go to the right 3. Just like you would with an x-coordinate of 3, okay? Because it has a -3 at the beginning, we're going to go left 3. Okay, everybody with me? All right, so we're going to go left 3. And right now, I'm not plotting the point because I'm not done, but that's currently where I am. Okay, I've gone left 3 because of the -3. The next thing I do is I move from that location around the circle or around the axes pi units. Or degrees, or not degrees, radians, pi radians. So if I move from where I currently have that last red marker located and I move pi radians, where will that end me up? On the +3 side. So over here is where I end up because I've gone through an angle of pi. So the point that I have right here is the point that we're referencing. Now, we're going to come back to this problem on example 3, but you should sort of have this feeling of that seemed like a strange way to get there. Why in the world did we go -3 and then go back around to where I was if I'd have just gone +3? Right, seems a little bit strange. So we're going to come back to this example, but this is the correct place that we would plot the point. Are we all good on that? Okay. We're going to intermix our radians and our degrees again in this section. Okay, so theta doesn't necessarily have to be measured in one angle measurement or another. It can be measured in angle, the angle can be measured in degrees or in radians. So this particular one is measured in degrees. So we've got a +6, which means how do I move then from the origin? To the right. So I'm going to go over here, 1, 2, 3, 4, 5, 6, And I'm not plotting my point there because I'm not actually stopping there, but that's where I'm starting from. And then I need to go negative 60 degrees. What does that mean? Pi thirds, or where will that put me? I should say it that way. It'll put me down in the fourth quadrant, right? So it'll put me down here somewhere. Yeah? So roughly speaking, here's my negative 60 degrees. And roughly speaking, I should have been a little bit less rough. So I actually need to move this particular point down to put me right here. And then this is a 60-degree measurement. And it's negative because I went negative, right? Again, there's other ways to measure that. And in fact, that's the next thing we're going to look at. All right, so taking a look then at problem number 3. Problem number 3 uses the same polar coordinates that we had on problems 1 and 2. And it wants us to actually find another way to represent that in polar coordinates. And there are infinitely many ways to do this. There is not a particular right answer. There are certainly answers that sort of are a little bit more easy to see than others, but there isn't a right versus wrong kind of an issue here. You may come up with something that I wasn't thinking of and it still be okay. I'm not exactly sure how my math lab is going to handle that. It probably will do multiple choice. I did not check that out now that I'm saying that. I'm not sure. And it is out there in my math lab, but it won't be due till Monday. So taking a look back at negative 3 pi, we actually were right here where we ended, right? So let's write this in another way. How else could I have done this? Instead of going negative 3 and then going around pi, what could I have done?
3, 2 pi.
I could have gone 3 and 2 pi. That's good. Sure. Somebody else was thinking something else, I know.
3, 0.
You could have gone 3, 0. Remember that 0 is not actually the y value, although 3, 0 in rectangular coordinates is also that point, oddly enough. But it's a degree measurement or an angle, radian measurement. What else could I do? What if I stick with the negative 3? I could do negative 3 and then negative pi. Right? I come over here to the negative 3 and then I go backwards, clockwise around the circle over here to pi. That's perfectly reasonable. What was that, TJ?
Negative 3, 3 pi.
Sure, you could do negative 3, 3 pi. Okay, so we could do this all day, right? When they ask the questions of this variety in your book, they give you some examples. They say they want, for instance, you to choose one that has a radius that's negative and has an angle that's between 0 and 2 pi. They'll give real specific which ones they're looking for in that sort of range of values. But I want you to recognize that all of these are the same coordinate pair, which is way different than rectangular coordinates. We do not have that feature for rectangular coordinates. All right, let's do the last one here along these lines. 6 and negative 60 degrees, and we ended up, roughly speaking, down here at 60 degrees. So, another example. I should make the mention, too. If you're starting out in degrees, we're just going to keep it in degrees. If you're starting out in radians, we're going to keep it in radians. Okay, so I'm not looking for a radian versus a degree interpretation of this. That's not what I'm going for here.
6, 300.
All right, so we've gone 6 and then 300. Make sense? Just went the other direction around my circle. Good. What else could I do?
Negative 6, 120.
Good. So if I get negative 6, I would have gone on the left-hand side of the graph, right? Left-hand side of the x-axis or y-axis over here. And then I've gone 120, sweep through 120 degrees to get where I am. That'd work. What else? Can you give me one that's got 2 negatives?
Negative 6, negative 240.
Yeah, I didn't give myself enough room. Hang on. Yep. So I could go negative 6, right? And then still go around the direction that would be clockwise, the negative direction around the circle, and end up same place down here at the bottom, at the bottom over here from your perspective at the negative 60 degrees that I went originally. And we could keep going, right? So I'm going to write etc. on the bottom of both of these screens because this process is a never-ending process. We could do this all day. We're not going to because you guys have to go and so do I. So have a good couple days. I will see you this Friday